Good evening, everybody, and welcome to Advanced Refrigeration Podcast. You're here with your host, Brett Wetzel, Kevin Compass, and Charlie Cunliffe from Microthermal. How we doing today, man?
Doing well, sir. Thank you for inviting me.
Absolutely, absolutely. Tonight we are going to be speaking about communication issues with Microthermal, and maybe we'll be touching on some other things that he wants to bring up. Um, Tell me about a little bit about yourself, Charlie. How long you been in the business? How long you
Uh,
been with
okay,
Microthermal?
sure. I've been in the business for 40 years. The last 31 years with Sporlin, and I was originally a mechanical engineer, selling valves and mechanical controls. But I guess it's about 14 years ago, we acquired Microthermo, and I took the lateral transfer over to the Microthermo division, and I've been working with them now, and applying Microthermo Alliance and Microthermo FMD to the field for the last 12 to 14 years. Predominantly, most of my work has been with CO2 installations. As soon as that became more prevalent in the United States, there was a great increase of microthermal application. Microthermal has been around for over 27 years, but before they were acquired by Parker Sporlin, they were predominantly, I would say, a Canadian firm, but for the last 10, 14, 15 years, we've expanded across the greater United States.
Okay. And so I mean, what are you doing currently at Sporland Parker?
Okay. Well, I focus completely on microthermo,
Mhm.
and in my position, I'm an application and specification engineer. So I'm involved from the first time someone calls and said, "Hey, we heard about microthermo. Can you come down and give us a presentation?" So I'll give I'll call it a 30,000 foot view,
Mhm.
and then generally, if they want to get a little bit deeper, I come back and do a more technical presentation, and then usually I stay with the client from that initial 30,000 foot view all the way through the first one, two, three, four stores that they use microthermo on, and then fully pass it over to our integration engineers. But the one good thing about my experience and the way Parker has our division set up, if I'm working with you guys, Brett and Kevin, I can help you if you have a question on a Parker Flowcon, an A8 or an A9, or a Sporlin EPR valve or microthermo. I can handle those questions for you because I'm experienced in both the mechanical and the computer control side of the systems.
Okay. And what did you say you did before working for Parker Sporland?
Before Parker Sporlin, I was actually in the supply business.
Oh wow. Okay.
HVAC supply business, and then from that to Sporlin, and then like I said, 12, 14 years ago when we purchased Microthermo, took that transfer over to Microthermo.
Awesome. Well, man, I appreciate you coming on. You want to get started in with the PowerPoint?
Yeah, sure, that's great, man.
All right, let's bring it up.
Okay, we all good?
Yes, sir. Go right ahead.
Okay. All right. So I just wanted to do a few brief slides. I didn't want to make this death by PowerPoint, but I wanted to talk about Alliance, a little bit about the protocol and the network, only because Alliance is different probably than a lot of the networks that you're currently working on, being that we're a distributed network. So let me just go over some of the basics of LAN. Now, there are other people who do use the term LAN or Echelon, and it's a proprietary. The Echelon that we use is the real deal. It's the international Echelon. We have to pay royalties. for every chip that we use. The whole idea with that is it enables manufacturers, no matter where they are from all over the world, we have to guarantee that if you get a VFD, if you get a rooftop, whatever the device is that you want to control, and it's Echelon enabled or it has an Echelon chip, we have to be able to integrate that directly in through Microthermal. So a Bacharach leak detector, you just get the Echelon enabled version with the chip in it, and boom, you commission it and integrate it right through the front end of Microthermal. So the whole idea is that it's an open technology available to all manufacturers, and it's a worldwide standard. So it's plug and play. And what we mean by that is if you want to integrate, let's say Danfoss happens to be a competitor of ours, but if you or your customer prefers Danfoss drives, we're really agnostic. We will integrate a Danfoss drive into our system. It's just it has to be Echelon enabled with an Echelon chip, and that way, as I said, we can program it or integrate it directly through our front end. No motherboards, no daughter boards, no licensing fees, etc. So when it's true Echelon, you've got to be able to program it, integrate it right through your front end, and it's got to be seamless, plug and play, without some of the other situations that you may or may not have run into. So being that it's all over the world, everybody has to agree that what we put out is open and interoperable. And just, I'm going to go over these terms very briefly because when I open up an application, you'll see some of these parameters in the background. A snivet, which is a standard network variable type, that could be an NVO, network variable output, or NVI, network variable input. UNIT is the opposite of SNVIT. That's standard. This is a user defined, or you might call it a custom. Then there are standard configuration parameters that everybody has to agree to, and then there are user-defined parameters, and then we have the same. I'll call it a thesaurus or a dictionary. No matter where it is, all over the world, objects, functional profiles. A sensor is a sensor no matter where it comes from. Actuator, HVAC, lighting, refrigeration pump, you name it. So again, the whole idea is we're all talking the same language. We're all using the same protocol information, so that any device, wherever it's made, as if it has true open Echelon, it's going to work through the Microthermal Alliance front end. So that's like 60 seconds on LAN. Of course, we could go into that much deeper. I really wanted to show the group this because these will turn up when I go into a live site. You'll see some of these descriptors, and just so that you have an idea of what you're looking at. And we've used, LAN for 27, 30 years now. I know other people are 485, BACnet. We've been really happy with Echelon. It's very granular. It lets us get down to the nth detail. The conductors we use are very robust. And again, it's used on bullet trains, subway systems, and in mechanical control systems all over the world. So that's why, at least for now, as far as I can tell, we're sticking with Echelon for our protocol and our communication. I think we're probably considering perhaps a BACnet option in the future, but right now LAN has worked so well for us, we're going to stay with it. So the communication that we use is FTT10. And that's 78 kilobits, 78,000 bits per second. And the topology we prefer is either star or free. And each network channel can go up to 1,640 feet. And we don't want daisy chains. I know that's a term that other communication people use. because it's rightfully applied for their technology. If you do go into a startup and you see that the communication or the electrician contractor has done a microthermo store and the network has been done in one gigantic daisy chain with a terminator on the end, run away, because it's not going to work for you. That's an Echelon violation. So I have used bus, guys, in extremely large commercial applications. You can see the speed is in the mega, but for supermarket, we stick with the FTT10 and either star configuration or free. And anytime, guys, jump in if you've got a question on what I'm going over, but I just wanted to give you a background before we actually jump into a live store.
Charlie,
So,
can you go over the
yeah.
difference between free and a star configuration? I understand what a star is. I'm not particularly
Okay,
familiar with
cool. Absolutely. Great question. Okay, so I prefer, Kevin, I prefer a star because for me, that's easier to troubleshoot. And what you would do is you would land the balancing resistor right at the center of the star or the center of the octopus, and then all of the legs are emanating from there. Okay? With free topology, I can do a star on a star on a star. This pretty much is it opens you free license to just make your connections any way you want to make them. The only caveat to that, Kev, is somebody darn well better make a hand sketch of how this was installed on the job, and then if you give that to us, we'll convert it to a CAD and we'll put it as a view in Microthermo, because this is totally, as it says, free. Means you can, as long as you observe, okay, 64 nodes per segment, no longer than 1600 meters, you can freelance with this and you can make your connections however you want to make a connection. So right here, you see that's a star right there, Kev. That's a star right there. That's a star right there. So anytime we drop off of another one, we call it a star. Okay, but the correct term for this is free topology, and really it's like a freelance, and you could make that network any way you want to make it. I mean, you could start with a main drop, a star, then you can have a star from a star, and then that tertiary star you made, you could make another star from that. So in other words, rather than this one where you start from a main starting point and you go in 1, 2, 3, 4, 5, 6, 7 different directions, okay, and then you've got channel A, channel B, channel C, channel D, channel E, okay. For me, that's easy to wrap my head around if I'm going to go to a store and troubleshoot. But with free topology, again, that's got to be committed to writing someplace, because, I mean, it's freelance. You can make the network whatever the heck you want it to, as long as each one of these subsegments, Kev, can't be any more than 64 simple nodes and no more than 500 meters or 1,640 feet.
That's how
Does that
that's how a lot of the daisy chain stores I see are ran. They're ran free, right? Like they're just ran all over the place.
Yeah, but we see with this though, this I wouldn't call this a daisy chain, because if this was a daisy chain, I would go here, then I come out of here and go over to, you know what I'm saying? It would just be one gigantic serpentine feed. This is, again, it's a simplified version, Brett. But again, this is a network segment, that's a network segment, this is a network segment, that's a network segment. So this is a simplified design. Let me go to up. Kev, do you have another question?
I had a real quick question.
Sure.
About the communication. You said that the only bus that you guys deal with is Echelon, correct?
We do, yes.
Okay,
And
so
again, that's just a bus network topology, okay? And we would use that for really for the speed. So I did a DNA lab, and I had hundreds and hundreds and hundreds and hundreds of nodes, and the temperature real-time reporting back was critical. A bus network topology there.
okay, so but I mean, does that limit you to what you can connect to, or does most equipment now have the capability? Like, if you take a NIDEC drive, right, and you want to communicate with it, they do have different plugins that you can plug in, so you can either make it communicate via, IP or BACnet or Modbus. It all depends on what card you have. So is that how you get around, just if you only, because I mean, most controllers have, different open protocols, right? They do have backnet Modbus, but I mean, does that really limit you, or does there a lot of manufacturers that basically make a lot of those adapter cards to
Uh,
make the drive or whatever talk to Echelon?
yeah, well, again, in the best world, we would like each device to be natively Echelon, but you'll see in a slide that I have coming up, we've done with Siemens, we've done some work with them where we can integrate their system. So we're open to that if they have an ability through a translator, for lack of a better word, where we can bring their communication into ours. We will definitely do that. So again, we'll take analog inputs. We do have the ability through adapters to get 485 onto our network. So again, we don't put a roadblock up against other forms of communication, but an alliance itself natively is Echelon for now.
Thank you.
Okay. So in the basic Echelon schematic, we have what's called the backbone. And then what we'll do is, again, now this is a star. This is a different version of the simplistic diagram. So a channel in larger stores will start with a router. So this schematic here has four routers or four channels, but we make a determination here. A lot of people always say, Charlie, where do I put my EOL, my end of the line terminator? And that is not what we want to do with an Echelon channel. We always want and I don't like it to call it a terminator because it puts people in mind that it's got to be end of line termination. I rather just say the resistor. You always try to look for the geographic middle of the channel, and that's where we want to land our resistor. So we have a resistor on the backbone. This is a star right here. I go to my first router. Go ahead, question. Okay, and then you see I start off of this node, I start off in this node. On this channel, I ran it down here, and then here's another star here. So again, this is not a daisy chain. In Echelon world, we call these networks or network segments. So this is a channel, and then you see a sub channel here, or a sub channel there, or a star here. And then another example is we come here, we drop down, and we drop over. So in this diagram, it's a kind of a mixture of free topology and star network, just to give you an idea of how open our network is. I mean, we allow you, as long as you stay within the Echelon parameters, we allow you to design the hardwired network to use the least amount of cable possible, because the Echelon cable, truthfully, is a little bit more money than standard communication cable. So we want the least amount of cable possible, and we want balanced resistance on each network channel. And never put the resistor at the end of the line. Always find the middle of the network. So another way of thinking it is like this. So this is a boiled down version of a supermarket network. And it starts with what the guys in the trade call a data logger. That's actually a Windows industrial computer. And it's on what we call the backbone. So we put a 53 ohm resistor on the backbone. Here's the star right here. And then we have channel A, case controllers, and we can have multiple channels. Channel B, we can have a channel for rack A, rack B, rack C. Here's another channel for the HVAC system, and here's another channel for lighting. So you can have multiple. You can have 4, 10, 12, 16 channels, however many channels you want. Again, we don't want any more than 60, 64 simple nodes, or no more than 50 compound nodes. And again, your resistor should always be at the middle. So at the very end, or the first thing, Kev, on the startup, what you'll want to do is get a multimeter out. And again, you want to never be any lower than 52, never higher than 58, no matter where you put the multimeter. If it's at the end, if it's at the middle, if it's out the router, check it in 3 or 4 places, but it should be within 52 and 58 ohms wherever you check every network segment. If you were on the HVAC system upstairs and you got to the end of RTU4 and it was 84 ohms, then I'm going to guarantee right now you're going to have a problem with that channel. They either used too much wire. They did one big ass daisy chain on the channel instead of doing a star where you cut down the amount of cable, or they did a bunch of courtesy loops or double backs. Again, everything should be as close to 53 as possible. Brett, Kev, any questions?
So far, both.
Okay, man.
No,
Uh,
it's good so far.
go ahead, Kev.
No, I said it's good so far.
Okay, cool. All right, so here's a biggie with the Echelon network, and if I harp on this, I apologize. I'd prefer you to use the Belden. I almost guarantee that if you use the Belden 16 gauge 8471 for both your main drop and your node-to-node communication, you will not have a problem with an Echelon network. It's 2-wire twisted pair, no shield whatsoever, 16 gauge, which is heavy duty for communication wire, and it's a minimum of 6 twists per foot. So it's the twist that actually creates like an EMF shield on the wire. I've had the bad experience of coming to jobs and, have guys do a big daisy chain and use the same wire cable that they would use for a 485 network. But I'd tell you right out, if you're going to do a store and you want it to work right with our technology or any Echelon technology, and by the way, this is an Echelon spec. This is not something that is dictated by Microthermal. This is an Echelon spec. So 16 gauge 8471. There are other substitutes out there, but be very, very careful. You can go to Echelon and check to see what substitutes they consider equal, because sometimes you'll get a supply house and they'll go, oh yeah, it's Echelon wire, and then you get there and it's 2 twists per foot, the impedance is different, the resistance per 1,000 foot is different, and then you got nodes disappearing, they're on or off. It's just not worth it. So I always try to tell guys, please stick with the 16 gauge 8471. Now our 500 platform uses a four lug network connector. Our new 700 system uses a 2 lug, and the reason it uses a 2 lug is we try to tell people, do not wire the network like this. We want both blacks bonded together and under the same lug, and we want both reds or both whites bonded together, twisted together, and under the same lug. That way, if this node gets smoked or somebody unplugs the network wire, you have not violated the network. If you wire it this way, if I have a problem with the node or I unplug it, I've now interrupted the network. So we try to preach that, but after a while we just said, well, we've got to do away with the 4 lug, and all of the new boards only have 2 lugs on them, so you can't make this mistake. So again, the network starts with the hub, the HMI, and the very first thing that comes out of the HMI is the USB adapter. Your black and white wire, that's the beginning of your FTT10 network, starts right there. The very next component that it's got to hit is the alarm node. Now, this is a real-time clock, and this is a scheduler, and this is a scheduler. So this board that you're looking at here is a compound node. This is a node. This is a node. Another one, and another one. So if I had 50 of these, that would be the maximum I would want on a network channel, because it is a compound node. We also try to pull the plug on this. We never want you to run the network in and run the network out of the board. So we pull that plug to make sure if you do get to a job and you see that somebody's got the network wire running out of here, start over. That's a no-no. You're going to have problems with the network. Because this is a main hub and everything communicates in and out of the alarm node. And if anything should happen to this, you're going to kill the network. So I gave you a picture here of an installation. Here's the HMI. That's not a master controller. Remember, all of these are smart nodes. They're microcomputers unto themselves. And then we program them and integrate them when we start up. So here's the Windows device, the HMI. Here's the USB adapter. Here's my black and white wire. Starts right from there. The very first thing I hit is the alarm node. Now you see there's no wire coming out of here, so that you can't make the mistake of starting your network from here. So we star over to here, and then we pick up these nodes, and then we go out to the building from there. Now, Brett, to answer your question that you had earlier, if you squint real hard, this is a Siemens, connector here. So this was, I think, a Campbell's Soup job, or it might have been an Aldi, and we had to integrate to the Siemens. And this, I'll call it a daughter board for lack of a better term, but this is the adapter that we used so that our technology and Siemens could link together.
And just so you guys are aware, what he was talking about before about those boards being smart, basically they don't need communication to the main or to each other in order to function. They will, most of the time the sensors are connected right to it for whatever function it's trying to achieve, and basically it can run independently. Now, if you have, I'm assuming if you have cases that are supposed to be going into hot gas defrost that have to energize stuff on another board, I'm assuming that wouldn't work until you get network corrected, correct?
We would have to have a physical violation of the network, but that was a great point, Brett. So the store profile is kept here for safety purposes, but each one of these smart nodes, think of it as a microcomputer. When we program and integrate right from the get-go, in fact, we do the programming before we even show up at a job. All we do is service pin it when we get it there. That associates back to the HMI, and all of the parameters, whether it's superheat, whether it's a pressure, back pressure, whether it's controlling the gas cooler, all of those control parameters are flashed to that smart node or microcomputer. Now, should something happen to this HMI, everything will synchronize to the alarm node. That's why it has a real-time clock. If anything should happen to the the alarm node, then each one of these nodes has its own internal countdown clock, but it will be self-operating at that time, Brett, meaning that it will, if it's a case controller, it's going to continue to run the lights, the fans, the superheater, or whatnot, but it will not be synchronized to the alarm node. So everything synchronizes to the HMI. That's how you report out to the real world. And then should anything happen here, then everything synchronizes to the alarm node with the real-time clock. And then, God forbid, if anything happens, they have their own internal clocks that they will work off of. But once I program this case controller here, and it's in a meat case, it knows what it is. It knows what it's supposed to do for defrost. It knows what the superheat settings are. So it becomes self-operating, and the network only is there for nodes to communicate with each other, if necessary. An example of that, Brett, would be, let's say I'm doing HVAC in the store. So I've hung a temperature sensor and a relative humidity sensor so the HVAC system works better. Well, the beauty about a network is now that's an Echelon device. It puts the temperature and the humidity on the network. So all I have to do is tell each one of these case controllers by checking a little box to listen to that parameter, which is always broadcast. It's an automatic broadcast on the network. Listen to the temperature and relative humidity, and guess what? Now the case controller becomes even smarter, because as the temperature rises or falls, or as the humidity rises or falls, the latent load and the sensible load profile is going to change to that case. And the case controllers get smarter because it's taken the feedback from the same node that's, given the inside parameters to the rooftop units.
And there was something Charlie said, and I just want to make sure you guys understand that this as well. He was talking about when he said the term you have to hit the service pin. On Echelon devices, they have what's called a neuron ID. It's basically like a board address, and that basically is programmed into the controller via, by actually, typing in the node address. Or the other option is to hit the service pin, which basically, it's almost like activating your Bluetooth for a headset or something. So if you hit that, it basically starts, scanning, sending out a signal saying, "Hey, I'm looking for this board."
That is correct.
And basically that's how that works. So just in case you guys didn't understand what he said about the service pin, I just
Yep.
wanted to give a brief description.
Yep. Great point, Brett. Thanks for catching me on that.
It's nice. It's also nice because it guarantees you get the right board.
Right.
Because you're physically going there and pushing the button.
Yep.
The other, oh, sorry.
No, go ahead, Brett.
The other thing that Microthermal is pretty good. So they have a function like if you're, sometimes looking up trying to find what particular board that you're looking for, it can be kind of difficult. They do have this function called wink, where basically, you hit the board that you're looking at in the program, and it'll make the service lights go on and off. Basically winking at you, say, "Hey, I'm right here. I'm over here."
Yep, absolutely right. So, being that we got into it, so what we would do, the very first node that I always start when I'm getting a store ready is I always start the alarm node first. So, I then go to the front end, the desktop, and I find the icon, the virtual icon that represents the alarm node. And then there's a button, a virtual button that says install. And there's an actual cartoon of a hand telling you to press a button. So what you do is you go over, squint real hard. You can see that that's a service button. You just press that for a quick quarter of a second. And what that does, Brett gave a great description. This looks back to the HMI. The HMI looks to this and says, "Oh, you're the alarm node." And boom, without you having to type anything in, everything that needs to be uploaded to this alarm node is done for you automatically. Now, yes, Brett is correct. If you choose, you could type in the alphanumeric because every chip has its own individual unique identifier. But for me, I'll fat finger it. I'll never trust myself, so I always use the service pin. So for the alarm node, being that it's a compound, I'd hit it here, and then I'd go to the icon for the real-time clock. I would hit this service button, and then I would hit the scheduler for HVAC and the scheduler for lighting. Okay, and you can have multiple alarm nodes on a job. You can have more than one. Okay.
And when you are doing this, it's a lot easier to actually have two guys on site. If you're not going to do the neuron ID, we're basically going to write down everything. Just be able to have the guy up there on the phone with them. "Hey, I'm ready to look for this board." Just hit hit the service button, and then basically it just makes it a heck of a lot easier having another guy on site.
So
one thing that I do, I'm sorry to interrupt, but one thing that I do is I bring a 4G modem with me when I start up a store, and I connect it to the HMI, and then I take a 4G enabled or a 5G enabled phone or tablet, and I can start a store myself because I don't need to be at this panel. It's good to have two guys, but if you can't have two guys, if you make this data logger able to communicate to the outside world, then what I do is this screen here, this landing page here, I see the same exact thing on my phone or tablet, and then I'll get a ladder, I'll get on top of the frozen food aisle, I'll take the cover off of 20 different case controllers, and I'll just start and service pin, service pin, service pin, service pin, all the way down the aisle. I just have to make sure that I'm on the right icon when I do it, so that I don't misappropriate a case controller to the wrong location. Kev, did you want to ask a question?
That's exactly how I do it. I use the 4G router, and then I'll use an iPad, and then I'll walk around and ping everything. It goes pretty quick until you get to the coffins.
Yeah. Now, one thing that saves a lot of time, and I'll show you where to find it, we have something that's called delayed install. And what that does, it sets up the initial handshake between the safety profile on the data logger and the case controller or gas cooler controller or whatnot. But then it just stops right there, and then you can do 100 nodes in a day. Because I'm going to tell you the truth, this alarm node here, that might take 2 minutes because it's not that complicated of a node. But a case controller, there's so many algorithms and whatnot, you could wait 5 or 6 minutes for that case controller to be fully integrated. So we have what's called a delayed install, and like I said, you can do 50, 100, 150 nodes. And the last thing you do before you go out of the supermarket and get back to the hotel and have a cold one is you go to the screen that allows you to do a delayed install, and then it picks up from where you left off, so you don't have to stand there and watch the screen for 5 minutes for each case controller. And overnight, while you're getting some rest, it's automatically integrating all of those boards for you and saving you time of having to stand there and get in front of just stand there, watch a screen while all the parameters are building for each and every node. Now, again, I'm new to your technology, so what I want to do now, Brett, is I want to log into a store for you and show you some of this in operation. So do I hit the stop sharing button for
Yep.
the moment?
Yep. Hit stop share.
Okay.
Hit share again, and then this time, bring up whatever it should. I'm
Okay.
pretty sure it says web browser.
Okay. All right. So what I want to do is I want to get my team viewer going here. All right. And then I guess I'll have to minimize that and then share screen.
Mine right now at the top says Microsoft Edge tab, Windows or entire screen. So it'd
Okay.
probably be whatever browser you're using, right?
And that's not going to be that. Hang on for a second. So
Yep.
let me get this up here. Okay. There we go. Share. Can you all see that now? Are we there?
There we go.
All right, cool. All right, so let me show you some of the cool things that you can do. Now, I listened to some of your podcasts, and I got to tell you, they're really good. And the speakers that you've had on talking about their type of networks, very, very good information. What we've tried to do with Microthermal, you don't need an oscilloscope, you don't need a signal generator. All you need is a multimeter. That's how technical you have to go. So let's say you're having a store with a communication problem. So the first thing you do is go right up to this tab here that says network, and then you're going to want to do architecture. Now what I'm going to do is open this up, and what this does is it gives you a complete roadmap of everything that the data logger is going to look for and exactly what chain it's in. So here you see the backbone, which I made reference to, and on the backbone you've got this circuit control, the alarm node, you got an MPC, you've got the HVAC scheduler, the lighting schedule, and the real-time clock that I told you about. Now in this store you have router 1, 2, 3, and you got a rack router. Now watch what I'm going to do. I'm going to drop down router 1, and then I'm going to drop down again, and now look, everything. So even if you don't give me a network diagram, at least you know everything that's on that router and the hierarchy or architecture that it's in. And any information that you want, if you just click on this, here's your identification. Brett, you brought this term up. Here's your Neuron ID is there. The device name is XN54. The next one is XN57. The next one's 56. The next one, 55. So I'm going in order here. Okay, so it lets you know the hierarchy of how the data logger is going to look for that, and they're all, as I said, FT10. So this gives you a roadmap of the entire store. So here's router 2. I'm going to do the drop down, and here's everything. So this looks like it's an HVAC router, okay? And here is the rack router. I'm going to drop that down. Yep, circuit control, suction control, gas cooler, MPC, superheat exchanger. These are the valves for the flash tank. So everything that you want to know as far as the architecture or hierarchy of the all of the channels are here. And again, all you have to do is highlight any one of those nodes, in all of the echelon values that you may need to know are there. So, okay, that's the roadmap. So let's go into the real world. So let's go, here's router 1. Now, I want to know what the heck is on router 1 when the guy installed it. He didn't leave me a map, so watch what I'm going to do. I right-click on here, highlight connections, router 1 cases, boom. Everything that's on that channel turns purple. So now that you know router 1 is taken care of, this is the communication channel for everything that you need to know for router 1. So you just go back here, you do cancel highlight. Let's see what's on router 2. Highlight connections, router 2 cases. Boom. And you see it's all of these cases here. So if you're troubleshooting, if you got a bad actor and you have a node that keeps dropping on or off, at least to try to find it, what channel it's on, you could do this. So you just do the highlight or cancel highlight. Now, when you are looking at the visualized network connections node to node, as long as every dot you see here is green, that means every set point is perfect. Everything, every temperature, every pressure is correct. If one of these nodes should ever go black, that means you've lost connection. Okay, visually, if you see a black node, it's lost its echelon communication. If one of these nodes were white, it means that it's not been configured completely. All right, so it's stoplight, green is good, yellow's caution, red is bad. That means you have an active problem. But the other the colors that you want to know about is black means you've dropped a node, or white means it's not fully configured. If you've dropped a node, you're going to get an alarm up here that's going to tell you that you've got a node failure or a communication failure. All right. So that's a simple way. So that's on the main landing page with case controllers. The same thing goes for, rack A in this store. I'm going to go to the suction controller up here. I'm going to right click and I want to know what are the nodes and points that are either controlled or associated by this microcomputer. I hit highlight connection, boom. Everything that turns purple is either a point that's connected to, or it is a device or board that's being controlled by this suction controller. Okay, so again, to cancel that highlight, you go here, you hit cancel highlight. Now, can you do it the reverse? Absolutely. I can go here. If I don't know where it's coming from, I can right click on this drive feedback. I can do highlight connection, and boom, that's it. So this and this are associated. They're working on a channel, and they're working or being controlled by this suction controller. All right. Go ahead, Brett.
Quick question.
Yes.
I know this is a communication question, but because we're looking at a transcritical rack, does Microthermal control their own inlet valve and
Oh yeah, great question. That's what that FGB was referring to. So yes, we have our own, and we've had it. We introduced it at ASHRAE, I guess about 3 or 4 years ago. Yes, we have a 2-valve controller that controls the whole back valve for the gas cooler, and the valve that is the drain valve for the flash tank. So yes, the flash gas bypass valve is controlled. And we'll do a store with the Danfoss valves. A lot of OEMs like to stick with the Danfoss, so plenty of microthermal systems are out there with the Danfoss. We monitor it, but we don't control it. That's totally standalone. However, yes, Sporlan does now have its own controller for those 2 valves. Absolutely.
Okay.
All right, so now let me go to this here, gas cooler. I'm going to hit highlight connection. Now you see what happens. Intuitively, I know this, but only one dot turned purple, this little dot here. So what I'm going to do is I'm going to zoom in on that dot. You see it right here? I'm going to click again. That's a custom node. Now, Brett, you made mention of this. You might have 25 or 30 of these ganged up all together. Now I know virtually where it is on the landing screen. How can I find it physically? And what Brett mentioned, you go to this wink button. Okay, you click it once, and what that's going to do, it's going to be the opposite. Our normal blink is 1 second on, 6 seconds off, 1 second on, 6 seconds off. When I hit wink, that board's going to be 6 seconds on, 1 second off. 6 seconds on, 1 second off. So you can look at 3 or 4 boards next to each other, and now I've identified the board that I'm looking for because I've used the wink function. Okay. Now, my network variables, I can see them. Those are the NVIs and NVOs that I was talking about. Now, this is deep in the weeds. I won't dwell here too long, but my rocket scientists, they're the ones that get into all of this. Most of what we deal with in the trade, we're dealing with everything that's GUI or icon based. We don't have to get into the weeds and do all of the zeros and ones. It's there, but just so that you know where it is. So that's information on the controller itself. We got a little bit of a lag here. Hang on.
What's
You got,
GUI? I've heard that term before.
yeah, graphic user interface. Thanks. If I use a term, we have a hang up. Oh, here we go. All right. So now, again, I can't do this because it's already installed. But if this node was, never used, virgin out of the box, and I've applied power to it, again, like Kevin mentioned, we put a wireless adapter in there, or we put a 4G cell, and then we'll open up Microthermal. We'll get to this node, and we'll hit this install button. And then you'll see a bunch of numbers and letters flashing in the bottom of the screen. That is how you initially bring this online, and all of the parameters are flashed to this just simply by pushing that service bin button. And here's your Neuron ID. Okay. If I ever have to recommission, I can do it from here, or I can do it from here, send configuration, and I'll show you a report later that tells you why you might want to do this. Who knows? Somebody cut power in the middle of when you're pushing the service button, so you got a broken install. The first thing we would do is do a reset. That's like a hard boot. It momentarily interrupts power from this, which is in fact a microcomputer, and then we can recommission it or restart the node by either loading node software or sending the configuration again. Now, if this has been going on and off, you can test right through the node just by hitting this test button. Right now, this node has passed all applicable tests. If you cannot communicate or there's transmission errors, that will show up by simply just hitting this test button. Okay? So your network variables, your lawn mark information, again, this is deep in the weeds. I won't dwell there. But if you really need to get to the nth detail with the nodes and troubleshooting, you can do it right through the virtual icon for the node. Brett, did you have a question?
Yeah. Is there anywhere in so in the network setup for CPC, you can see how many COM errors it had. They in Novar they call it coefficient errors. Is there a screen that you can show us where basically it shows us like how many errors
Absolutely.
each board had or whatever?
Yep. So let me go to network, and I'm going to go to node statistic reports. And let's just see what's happened. That's a year. Let's take a look. Let's go back to July. We'll go to July 7th to October 7th. I'm going to hit OK. And then these are most recent errors. None. This is clean. So let me go back further in time. Let me go back to May. Okay. Most recent errors. No errors. Okay, let me go back to April. April 7th, okay. MRE analysis, none. So this store is running so tight. Let me go back to March 7th. Okay, MRE analysis. Okay, there we go. Let me
That's what I'm
open.
looking for.
Yeah. Did you guys know that this report was there?
I didn't.
Okay, cool.
No.
Yeah, so listen, look what this does. So here, you were asking about the throttle and the flash gas bypass valve,
Mhm.
what subsystem it was on. It's on rack A, most recent errors, and it's an invalid domain. This error could occur if the network configuration is invalid, if the network management tool is malfunctioning, or if the neuron chip firmware image is corrupted. Action: try reloading the node software. So what we try to do for you is we give you the tips of what to do in case you have errors. And again, you're new to microthermal. We try to give you the description of the error and some action that you can take. And then you can see the count here was only one error, so that's not gruesome. But it's especially on something as critical as the throttle and the flash gas bypass valve. Yeah, this is a node that you want to make sure is doesn't have a problem. So what I would imagine is let's close this out. So that was March 7th. So let's see. Let's go to April 5th. Okay, let's do the analysis. And let's go to April 13th. Analysis. All right, so see, so he took care of, the technician doing this store took care of this. So they were there in March, but you see no more errors. Now there's another thing you can do to ping the network. You can go back up to the network button and test all routers and nodes. Now I won't do the entire test because there's probably 100 or 200 nodes in this store.
Yeah.
But what I can do is just here, gas cooler. Now let's go multi-deck meet. Here's the node details. And right within here, instead of going to that report, Kevin and Brett, if I go to this question mark, this shows me recent communication errors. No errors.
Okay.
So I can either go to that report, the MRE report, or when I'm inside the node itself, here's the communication error situation. I always go to this question mark right here, and no errors found. So that's another test that you can do.
Hold on. Is that those other numbers over there? Is that important to anything? So like if you have this type of error or this type of error, this could be this common issue or whatever.
Uh, no, if you want that detail, what you should do is go back to that MRE report, Brett. Okay,
Okay.
so that's just going to enumerate the amount of errors that you have. But if you want some assistance, like helpful tips on what to do, you would definitely want to go back to there. Okay.
Okay.
So while I have this highlighted, remember I could test when I was within the node. I could also test from here. So simply test node. And here it is, test OK. So I could either do a test through the node front end itself or through this report. Okay. I'm going to come back to this report. And let's go back to here. So let's see, we did the node statistics. The analyzer. This is something I think, Brett, you were asking. This is another analyzer. What this will do is give you the amount of updates. And you see right here in red, so I'm going to hit refresh. What this will do is this will tell you if a node, maybe because of high voltage interference or whatnot, has been corrupted and is talking too much. But if you see things. If you see like 20 or 30 or 40,000 updates, that's a node that's just gone off kilter. So if you're in the 1400s or the 1300s or down in single digits, that's a node that's working fine. Okay. So that when I first brought this up, that was an old report, and that might have been left there since startup, where of course you're going to get a ton of errors because everybody's violating the network with turning power on, off, connecting and disconnecting things. But you can see that this is a very tight system. So here you have the node identification, the NV name, the subsystem it's on, the elapsed time, the number of updates, and the update interval. Okay, and this is helps you find if you've got a node that's gone off the rails and is just spitting out a ridiculous amount of information. Of course, what that does, it's going to bog down the entire network because it's just putting out quadruple or quintuple the amount of communication packets that it should be doing, and then you wind up dragging the whole network down. So this is a good report to do. So this is by update interval, and then you could also look at it by NV. And again, this will give you the number of updates. Again, who, why, what, when, where. Any questions, guys, on that?
I just had a comment. So, I
Yes.
mean, one of the things you can do, if you have a numerical value being present about, how many errors that you've had, see what it is at first when you first get on the job site. Recommended that maybe you reset it and see how often the error is coming through. Monitor it for about an hour. You'll be looking over the prints and everything else, trying to figure this thing out anyway. And then basically go back and see what it was, see what it is like after you had made a repair, right? So if you found weird resistances when you were checking the Echelon cable, right, and you weren't getting 53 on both sides, you were getting something crazy. You fixed a certain connection, came back, reset it, and see if it's coming in and out less now to see if you actually made an impact on the network.
Yep. Good point. Good point. And it's always good. What I always do is after the stores run for 5, 7, 8, 10 days, I would always come back in remotely and do a reset because the amount of alarms, the amount of network errors and whatnot, because people have their hands all over the system. And like I said, somebody is working on something and they turn the power off to the system inadvertently. It creates all kinds of errors. The microthermal control is always gets shipped with a UPS. So if somebody turns all of the frozen food aisle off, the HMI is still going to be looking for it. So it's going to go, oh my God, where's this? Where's this? So it's going to start spitting out a bunch of lost communication errors, and and that stuff, that's normal. That happens on a startup. So good housekeeping would be, come back 7 days, 10 days, 14 days, and clear all of that stuff out, and then, like Brett said, then take a look, a day later, 2 days later, and make sure that if you were having a problem, that you did solve the problem.
You could also have one board or one section of communication that could be actually taking out the whole network. So sometimes what you would have to do at that point, and I know we've discussed this, where basically you start breaking down the network. So if you got 4 connections that are going out into the store, and the whole store just keeps going intermittently, just on and off, as far as communication, what you can do, unplug all the communication cables, plug in number 1. Oh, wow, it's really steady. Nothing's really happening. Plug in number 2. Still running steady for the next 10, 15, 20 minutes. Plug in number 3. Oh, they all went to hell. So then basically you would unplug 3, plug 4 back in. Now you at least have 3 good networks, and now you can work on trying to figure out what on that network is causing you to, basically have your issues.
Right, and short of doing it manually, you could go up into the network tools here and then use, again, either testing all routers and nodes, which will be a little bit too long to do for this show, but that would do that for you, or doing the node statistic report would be a way of doing it. Now, I don't know if we have time for this, but I do want to show you the network quality. I guess you might be able to edit this after, but I do want to show you this. Well, let me do one thing. So I'm going to highlight a node here.
Mhm.
And we did, you can see the node details. We talked about this. Now, the location, your description, your neuron ID, and then again, here's all your communication errors are going to be listed here. So here, this one, since the last time it's reset, it's got a total of 890. I don't have permission to do this, but if I wanted to clean house, I could reset the counter to 0 if I'm sure I've taken care of the problem. And then again, if you're looking for most recent errors, you just hit that question mark there, and it'll tell you most recent errors. Now, let's just, if we have time, I'd like to show you this network quality, but that is going to take 5 minutes to do. So, did you want to just talk freely while this is doing the test, or you want to edit out the time? You tell me, Brett, how you want to handle this.
Let's
We can
do it. And
talk
we'll
through
just
it.
talk. Yeah, we'll
Okay,
talk through
cool.
it.
Okay, cool. So now I'm going to do network quality. So the first thing it asks me is, do you want to reset all communication errors and nodes first? Yes. So this is going to take a little bit of a time. But what this tool does for you is it's going to look at everything. It's going to look at every node. It's going to look at the communication errors, etc. So now it just reset everything to 0. And I'm going to hit the button that says Start Test. So I'm here to tell you, if you want to make a note of this, guys, we consider a very good network if you get a quality rating of 11 through 20. If you get a network quality more than 20, a 30 or a 40, then it's time to start, your detective work, like Brett was saying, and start looking for where either you have excessive resistance in a channel or a sub-channel, or you got a node that's chattering too much. So again, you want to be 11 to 20, and if you have a super tight network, you want to be from 0 to 10. The closer you get to 0 on the test, is excellent. So anything from 0 to 10 we consider to be an excellent, very, very tight network. So right now it's thinking. That's why we got the spinning blue wheel here, and it's probably going to ask me if I want to do a bunch of clearances. And then you'll see the clock. Okay, the network quality test will not be accurate. Reset any node. So I want to do yes. And you see now it's starting down. So this will take 5 minutes. So I'm going to throw it back to you. And anything you want to get out there, anything that I could explain while this is going on, I'll be glad to do that.
So Charlie, on the actual nodes, so say you're like troubleshooting a node, you got one offline.
Hmm.
It
Yeah.
Oh, his internet.
Uh oh. So after we do this test, maybe I'll go back to a node and just open the node itself up, Brett, and hopefully Kev could get back on, and maybe we can do some virtual troubleshooting of a node right within the icon itself.
So, how many nodes are you limited per either branch of the line or on the whole system entirely?
Okay. The number on the whole system is so large, I would have to look it up, Brett. But again, the network, let's say Bible by Echelon is this. You're allowed to have, as far as cable length is concerned, 1,640 feet. And within that 1,643, if they're simple nodes like an MT500, 508, 512, you can have a total of 64. We round the number down, we just say 60. If they're compound nodes like the case controller, we say 50 because they're communicating so much when they're a compound node. Now, if you need that segment to be bigger, what you can do in Microthermal, and I should have said that when I had the PowerPoint up, you can start a channel with a router. You can go 1,600 feet for 64 nodes. Then I can put an Echelon repeater, and then I can go another 1,640 feet and another 50 compound or another 60 simple nodes. And I can have as many channels. There is a maximum. I don't recall what that number is, but I've never, ever, ever gotten close to it. Ever. It's a large number. I'm sorry that I don't know that number off
No,
the top of my head.
you're fine. Kev, go ahead and finish your question. I'm sorry, you cut out.
Yeah, sorry, my crappy internet went out again. So say you have one board, Charlie, just
Hmm.
for everybody. say you have one board offline, and you're going through it. It's got power. You can't get it online. Where do you go next with it with microthermal?
Okay, all right. So if I've tested and I've got power, if I've done the network test, and I've done the the communication test. Actually, what I would do at that point, we keep plenty in stock. I would pull that node out and replace it. I wouldn't go any further than that. I really don't have that happen very often, but if I was doing the full microthermal class and it was a simple 508 board, there are test points where you can check, okay, I've got 24 volts coming into the board. Now, some things like simple switches and thermistors, they need the 5 volt circuit. So there's a point on the board for ground and another 5 volt test point, and you can see, do I have a 5 volt circuit? Yes or no? Then transducers and complex devices like a combined temperature and RH might need 15 volts. There are other points where, again, ground and 15 volts, and you can make sure that you do, in fact, have 15 volts present on the circuit that is supposed to, power those complex devices. If it is a combo board that has relays, there are momentary switches that you can toggle back and forth to physically hear the switch make or break on the control itself. And if you're close enough, you can hear the that's a pilot relay. Then you can hear either a big relay make or break, or either a fan come on or off, or a compressor come on and off based on the action of the momentary switch. So I would do make sure that I have power. I would then make sure that it's not a violation in terms of the board wasn't programmed completely. So I would hit the reset button, which is momentarily takes the power away and wipes the temporary memory, and then I would either reprogram it or send the configuration back to the node. Sometimes it was just a broken install. Okay, so if you've done everything that I said, you tested the voltage, you've done the internal node test, you've looked at the recent error reports, you've done the physical tests on the relays, and then you've you did a reset on the board, and you sent the configuration again, and the node still goes offline, then I would replace that node, Kev.
All
Simple
right.
enough.
Okay, it looks like we're getting close. We should. The test is over, so we should get a value on this shortly.
So
So again,
oh,
go ahead.
sorry. Real quick before I forget. So we were talking about voltages. The reason, guys, why that's really important is, most boards have a certain range that they can be high and low. It's important to pay attention to that, because if it does go lower than what it's supposed to, a lot of times you'll start having draws on, basically your network, because it'll be too low. Or if you have an input board, you could have sporadic numbers reading on there, because it's basically changing your voltage, which is changing, the reading that it's supposed to be getting back to the controller for your temperatures. So I've seen a lot of times where, it'll say that it's supposed to have a 240 transformer, but, maybe they messed up and it's supposed to be, 208. Well, basically that's going to throw your voltage off. Especially most of the time you'll see this in the peak of summer, because the hotter it gets outside, more people are turning on the air conditioning. We're just putting draw on the voltage on the grid, and basically your voltage is all the way in the toilet, causing your any of your controls or anything to malfunction. What's the lowest voltage that Microthermal can run on their boards?
It's plus or minus 5%. No more, no less.
Okay.
Yeah, plus or minus 5%. Now, this is an incredibly tight network, one of the best that I've seen. So, remember I said that 11 to 20 is very good and 1 to 10 is excellent.
Yeah.
This is 1.3. So, that means the actual physical wiring itself, all of the connections, all of the amount of errors since this store has been running. Again, I've this is one of the best stores that I've seen. 1.3, it's as close to zero as I've ever seen. So this is a very, very tight network. So you would expect no loss of any nodes, no loss of any information, nodes not dropping off and disappearing. This is a tight store with a tight network.
You need to find me a store that looks really crappy as far as the network. I was just interested on like, all the numbers and like, how bad it was going to be, right?
Oh,
All right.
I've seen a store recently where the electrician daisy chained all the rooftops,
Uh,
and I'm talking slow. Like as soon as you unplugged all the rooftops, I mean, Alliance would run fast. It was speedy. As soon as you plug the rooftops back in, everything was just slow,
yeah,
and I mean
yeah,
the network
that's
was
yep.
terrible.
Yep. What you should do is just come up with a drop to the roof, and then if there's six rooftops, just make a six-leg spider and just pick each one up individually. He probably just did, like you said, Kevin. He probably just did one big ass daisy chain from one to another. There was probably tons of extra cable and whatnot. Yeah, if you put a network segment in or a channel in and it bogs everything down, that's absolutely a violation, and that's a dead giveaway. So that was a good heads up if you call it that. But what you wind up doing? Did you have to have him rewire the network over there?
Well, he didn't end up doing it. I ended up doing it.
Okay,
'Cause
okay.
they were gone by then, so it became the
So
startup guy's problem.
what was
uh,
what were the numbers before and after, Kev?
to be honest, I didn't really check. I just knew that that was the last part of the job. So we just knew as soon as we brought the HVAC online, it was nothing but problems. So I didn't really check that at that point because we already knew there was an issue, and we saw the daisy chains. So right away we knew we had to start. We had to move a bunch of them around. We ended up having to star a couple, and it got a lot better after we made a couple stars and got rid of like the big part of the daisy chain at the front of the store. I
Yeah.
mean, it got a lot better.
Oh, there's one thing that I want to show you, which is pretty cool. Let's see, do we have one on this store? Go back to yeah, here, something we call an MPC. I'm going to open this up for you, and this is not really network, but what this does is this allows you to take one of our standard boards and jailbreak it. So you see the node type is a 508. Okay, so that has eight. All of our 500 boards have 8 universal inputs, okay? And then the number 8 or 4 or 12, that tells you the amount of relays that are on here. So here's what's being input to the board. Universal 1, Universal 3, all of these are unconfigured. So this looks like it's the refrigeration trailer out back, and we're simply, taking the temperature. But this is the cool part right here is the network. What this does is it visualizes for you all instead of all of the ones and zeros and getting into C++, what you do is you from these palettes you drop down. Okay, so here's digital input 1. It's a switch. It's going to NVO. It's also going to the timer, and then out of the timer it's going to go to DO7 and DO8. And he did a good job here. Alarm silence. If the button is pressed, DO8 will open NC contacts for the refrigeration alarm board relay number 1. If a new alarm comes in the board, relay will pulse and will reset the silence. And it looks here's a gas cooler water drain. So this is part of Microthermal that actually lets you get in and write your own program. And you do it, again, I use that term GUI, graphic user interface. What you do is you're pulling down what you need, an NVI, PI, an NVO, or whatnot? Do I need a PID? Do I need a timer? Do I need a sequencer? And if you can think it and draw it on a pad, then you do it on this palette here. And this is how you do a custom program of a microthermal board using the MPC, which allows you to, we try to think of everything off the shelf for boards. Okay, you want it to be a gas cooler, you want it to be a condenser, you want it to do a chiller skid. But what this does, it opens it up or jailbreaks it, for lack of a better term, and you can do custom programming of a 500 or a 700 through the MPC.
Do they have them for the seven? Can you do MPTs in the
Yeah, yeah,
700?
yeah, 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 yeah. We got it now. Yep,
Oh,
yep.
beautiful. Yeah, I was waiting for that. That's going to be real nice.
So
Is can you have multiple boards in a train on a 700 board?
yes, they all have to start with a 722F, and that's the main microcomputer. And I can have, depending upon the utilization, a total of another 10 nodes plugged into that lead 722F.
Oh, see that's awesome. I mean,
Now, the one thing that Kev, you and I discussed this, when it comes to racks, it's not a limitation. It's a rule that we put onto ourselves, especially with CO2. There are certain inputs for oil, for temperature, for pressure, that we want absolutely to be instantaneous. So they have to. This is just the way the engineers want it. They have to land directly to that board. We don't want to take it as a network broadcast, because no matter how fast the network is, there is still a lag time when it's a broadcast variable rather than a pressure transducer that's wired directly to the board. So I just want to make sure everybody that listens to the podcast knows about that when it comes to controlling a rack, especially a CO2 rack. Back pressure, head pressure, gas cooler, outside ambient or whatnot. There are certain things that have to be home run, hardwired landed to that MT700 that's controlling the rack or the gas cooler, because we don't want not even a half a second delay in that information being available to the node. Other than that, you can broadcast. So like if I have a multi-deck with a case controller and I want it to be smarter, and I want it to know what is happening to the inside relative humidity and the inside temperature. If it gets it at a quarter of a second or a half a second, or God forbid 1 second lag because it's a broadcast network variable, that's not going to foul up the case controller at all if it's a little bit slow getting that broadcast information. But my guys in engineering feel that they don't want any type of a lag when it comes to the nodes that are controlling a CO2 rack and a gas cooler. They want it to be real time, landed directly to that train. So they all start off with a 722F, and you can mix and match. You can have input boards, you can have valve boards, you can have combination where it's inputs on the bottom and relays on the top. Where the 500 series kind of locked you in, there wasn't a lot of flexibility. With the 700, you have much more flexibility, because that 722F, that brain is so much more powerful than the micro computer that was on the original 500 series.
I
Charlie?
would I would love to get you on again, Charlie, just to go over like the 700 series boards and
Okay, sure.
their programming, and then also we've had like a ton of requests for you guys to like come on and go over MPCs, like just like a light like build how to build an MPC, like go over the program. I mean, guys have been asking for like nonstop.
Yeah, well, what I'd like to do, especially with the MPC, is maybe get somebody like Michael Morissette,
Yep.
one of our resident geniuses up at Montreal, the guys that write MPCs all day. You know what I'm saying? He would be I know how to apply them, but to have somebody really, give you a 101 on how to do an MPC, yeah, yeah, we can work something like that out, no problem.
Charlie,
Yeah,
how do you get me the software for the to make all those logic statements, so I could practice that.
I can send it to you. You can download it. There's a demo version of Microthermo. It just comes on a regular zip drive. So what you can do is just anybody listen, send me an email, and then I'll get you. We're up to I think version 8.3 on the device, and it's going to do about 90% of what you can do in a real site. So you can build a rack, you can drop case controllers and whatnot, and it functions almost like a real site. So yeah, that's our demo program. And just make a note, it's real simple. The user ID is demo, DEMO, and the password is demo, DEMO. Yep, and it's on a little zip drive. We send it to you. It's got to be loaded on a Windows device, though, Brett. It's not going to work on an Apple computer or whatnot. It's a Windows driven application, so it's got to be on a laptop. I prefer Windows 10 because the version 8 and higher is so much powerful. Windows 7 was okay for like version 6, version 7, but hopefully you got a version 8, excuse me, a Windows 10 laptop. It'll work the best on that.
Well,
Well, that's everything that I can think of. Is there anything in terms of troubleshooting that you were looking for that I didn't touch base on tonight?
no, I think you did a great job of the network stuff. I would love to get you back on and maybe go over the 700 series and 500 series stuff, and then eventually break out into some of the MPC stuff. I think guys will love that, and I think it'd be pretty good.
Yeah. Yeah, we could again. It may not have to go as long as this one, but we could do one on just 500 hardware. Okay, I can talk about those test points that we talked about earlier, and the ins and outs. How many analog outputs, how many inputs, etc. And then we can do another show for 20 or 30 minutes just on the 700. Maybe again try to what I can do. Let's see here. Let me go to the rack. Let me see. Let me open this up. See, that's what the 700 looks like now, and it's so much nicer. You had to be use microthermal all the day to every day know where all of the information was in the 500. But we've again, you go to the library stack. I call it the stack of knowledge. So anything about the rack, the discharge group, the suction group, one suction group two, you would find from this stack here. Your configuration. So everything you needed to know about the configuration. But the cool thing that I wanted to tell you is with the 700, this is what I like. You get an actual, a virtual picture. So it starts with the 722. So here, this is VFD speed. VFD speed. This is pressure. This is a simple switch. So you just hit this arrow. So it looks like we've got the 722. We got a 784. We got another 784, and we got another 784. So if you see green, that means it's available. But you see how this Kev, it's mix and match. I got a switch next to a temperature. I could have then a pressure. You can mix and match it and purpose this where you really didn't have this kind of flexibility and liberty with the 500, with the 700 system. I mean, here, pressure, temperature, switch, okay, feedback of the drive. So again, it all starts with the 722, which is a super powerful brain, and this has another 1, 2, 3. So I can have a total of the brain and another 10 nodes plugged into it if I needed to.
Can you do the same thing you're doing there, except for showing me the nodes for the inlet pressure for the inlet pressure regulator for the flash tank?
Hold on. So let's see, where do we have that? Let me get out of here.
So that's going to be a 700 something, right?
Oh yeah. So let me find out where they got that. So
They were pretty good.
Oh, here it is.
Yeah,
Here's
well,
primary throttle and FGB control.
Here we go. Let's check it out.
yeah, they were pretty good. We did like 2 or 3 stores with them, Costco's with them. I mean, they
Yep. So this is the 700. It's a 2-valve controller. So this one just takes a special brain and a special controller. So not only, so we said, hey guys, now that you did this for CO2, you could do other things. What do you mean? I said, well, how about if I had a CDS before and after, just a regular receiver, or how about if I had an A8 or A9? So now get this, we make a motorized head that you can retrofit onto an A8 and A9. And back from my days when I was strictly a mechanical guy, I would do classes and Charlie, wait a minute. Which one do I do? Do I do the A8 first, or do I do the A9 first? So to take all that mystery out of how do you set those valves out, you put a motor on the 8 and the A8 and A9, and then you use the 2-valve controller to feather. One is a holdback valve and one is the receiver controller, just to control the receiver in a standard system. So it's cool. So on this, again, you got the question mark here, and again, help on this system page. So anything you want to know of what this is doing is on there for the question. So here's your inputs. All right, so we have pressure, and here's the model number of the pressure transducer we're using. Here's an onboard diagram, so you don't have to run and find a catalog. So your common and your shield are together, and then your signal is coming in on the white, and your power is coming in on the red. And the cool thing we did on the 700 series, one thing that a lot of people are concerned about, and when I do the hardware class, the 500 boards had to be a center tap transformer. They had to be, because of the way they split the 5-volt and the 15-volt circuit up. The good thing about the 700 series, you look at the VA value for each, for the brain in each one of the nodes. Just make sure your transformer can handle the train, but it's just a standard transformer now. It does not have to be a center tap transformer. And that might not sound like a lot, but brother, go try to find a center tap transformer in the United States when you need one. That's bit me in the butt. I can't tell you how many times, if somebody smokes one of the older 500 boards, they can't be fed with a regular transformer. Okay.
All right. What's have we at? We at outputs right now, or?
No, we're on the inputs. So here's I've got my pressure, I've got my temperature, I've got now see, this is bound, so this is coming in from the network. T08, that's direct, and that's just an orange lead. T21, that's another 10K2 orange lead. So that's the inputs, and let's see, what are my outputs? Okay, so it's a Sporlan. Now there's other valves that we look. See, we're agnostic. We can use an Alco, we can use a Danfoss, or we can use a Sporlan. So this store has a GC30. It's programmed radius. What does that mean? The inlet is coming on the radius of the port. And, they used an SDR4 here for this valve, for valve 2. So again, Sporlan or the other manufacturers that I told you about. This happens to be an SD4, and here's the current percent open, and if I was going to override it, I could do it right from here, but yeah, here's the initialization, here's the LAN information, here's the drive information, and same thing over here, general, limitations, initializations. So this is the only one, guys, that looks like this, because this is a specialized valve. What this does is it controls 2 valves concurrently and simultaneously, so they feather back and forth. So this window is different than any of our other 700 windows because of the specific purpose of this combination here. Again, strictly we designed this to control the flash gas bypass valve and the drop lay coming out of the gas cooler, and they got to work in tandem. Just to close this picture, so what we have going here is, again, if the CO2 has gone past the critical point, and I've got a supercritical undefined fluid, then I have to make sure that I can have enough of a pressure drop here so that I can urge that CO2 to come back to a liquid state. Over here, I'm sorry. And then again, it's got another valve that bleeds off to the low temp suction. So through a suction and through the drop, we're always trying to maintain as close to 100% liquid CO2 in the flash gas bypass at all time. And again, I notice with CO2 systems, you're doing well if you can have 2 or 3 or 4 degrees of subcooling. I've not seen one yet where you can get 8, 10, or 12 degrees of subcooling. So you got to be careful with your piping and whatnot to make sure that you've got 100% liquid CO2 getting out to the store. So yeah, that combination of those two valves by that controller, that's where a lot of the magic happens in a transcritical CO2 system.
Kevin, how you probably looked at a bunch of the graphs for these. You've always said that the 326 controller has a decent program in it, but normally, if you get it right off the shelf, you're looking like a 40 or 50 pound differential between, the flash tank and, basically the high and the low for the set point. What have you seen when it's being controlled through microthermal?
I mean, it's the same way until you tune it. I mean, after you tune it, the microthermal one's just as good as the Danfoss one. It doesn't matter what it is. The stock settings never work. You know, everything has to be tuned, and that's the beauty about microthermal. You have more tuning set points in the microthermal in that two valve controller than you do the Danfoss. So
So,
you have a little bit more flexibility with it, and it's a little nicer in that sense.
mhm.
But Danfoss is easier canned. I mean, but you get more flexibility with programming and tuning on the microthermal controller. Like
so
I was able to get the receiver pressure at like an 8 pounds, 8 pound swing max, which is pretty good.
yeah.
With the two valve controller, and that's with me having limited time on it, messing around with it.
Where is that in the settings? Like if Charlie goes back to that, where would that be? That obviously not inputs or outputs. Is that more in the detailed, or where is that?
It's in the PID settings.
Oh, okay.
Get out of here and let me go to, we may have to blow up into this, and gas cooler.
I'm sorry. I'm excited here because I don't get to go real
Yeah,
deep into
yep.
my.
On your jobs, have they been in an MPC, Kevin? Where the PIDs for the gas cooler was? Where did you find them in the jobs that you were working on?
All mine were in the 700 boards,
Uh-huh.
like for the
Okay. So it's going to be in the block diagram here, the way this guy did it.
yeah. I've never seen them in the block diagrams.
Okay.
All of ours were actually in the actual 700 board. You would go into the 700 board, and all the settings were inside of there.
Yeah.
Once you opened up the little three lines, and you actually went into the setup of it, you could change like the throttle range, the flash gas
Yep.
bypass, uh, minimum percentage, and all that stuff.
Okay. And that was probably. Is it all right to mention the manufacturer? That was probably a Hill store.
Zero zone.
Oh, Zero Zone does it the same way too. Okay, this is an LMP store, and the reason they jailbreak that with an MPC is because they're doing other things. You see this here; they do actually liquid injection. They do heat exchangers, so they add a couple of extra bells and whistles, more than I've seen on other stores. So that's probably why they did the jailbreak, and they have that MPC on the gas cooler control rather than something off the shelf. So again, it looks like what they did on the gas cooler here is they actually wrote a custom program for that.
Yeah. See, mine were all Costco's, and
Yeah,
you guys
yep,
and
yeah. It was
Microthermal had
Yep, it's off the
100%.
shelf. Yep.
Yeah, 100% control. It was however you guys wanted to control it. You guys were
Yeah.
the complete control
Yep.
integrator.
Yep.
So
Yeah, I wish I could go into a Costco, but they don't like me to do that, so I can't do that. But Kevin brings up a good point. Any store, especially with Microthermal, it will run as good as you set it up. So an easy way to explain that, I'm going to open up a case controller. And let's just go to this me case here, and it's programmed off the shelf by my integrator, and that's as close as he can figure to make this board as smart as you want it to be. But if you have the time and the money on the job, the first thing you want to do to see, okay, how well is this controlling, go to the graph. That's pretty damn good. Let me blow this up. I wasn't expecting something as tight as that. The blue is the set point, and the green is the actual temperature. So you see this case controller is working tight. If somebody doesn't do their due diligence, this can be super spiky and all over the place. But again, what are some of the things I would do to tighten up? I would go into graphs, and I would go into valve position. So let's go percent valve open. So you see that? Look at that. This guy, whoever is doing this store, they got this brother on the money. So I close for defrost. I open wide right after defrost, and I drop like a rock as far as I can, and then I'm modulating right around 40%. So stay with me here. So I'm going to go to control. And all right, he's got the base open of 30%. I might say it should be 40, but with those linear graphs, and the refrigeration range is 30 times 2, so the maximum this would ever go is 60. And again, this is all going back to the graph again, so let's go back to the valve percent open. um, you know what they're doing for regular refrigeration is they're noticing the valve never really has to go much beyond here. Your average is 37.3. Okay, so why let the valve go 100% open if it doesn't need to go 100% open? Then the other thing you do is you go to your superheat, and that's pretty steady superheat right there as plus or minus. Now again, with CO2, don't be alarmed. That might be a little bit higher than what you would expect, but with CO2 control, as far as superheat is concerned, okay, it's really working in the background to prevent flood back. But as far as the configuration is concerned, it's temperature control priority with superheat as a backup. So that's why you might see, superheats that are a little bit higher than one would imagine. But if you do your job right with Microthermo, so this is a 2 temperature, this has got a set 1 and a set 2, but that's the kind of graph you want to see. If you see a graph that's all kinds of spiky, then you haven't done your job. So you should see your peak up like this on defrost, and once I go back into refrigeration, it should drop like a rock, and that's the way it should run. Totally linear, right on top of your set point.
And the more
yeah,
linear you get all those graphs, the better off all the rest of the graphs are going to be as far as all your pressures and stuff. Sorry,
Right,
Kevin.
because you're right, Brett, this is compound. So imagine 150 nodes in the store, right? If they're all over the place, then your load coming back to the rack is going to be bouncing all over the rack place. So now your rack is going to be unstable. So that's the key. Start at the evaporator. Get that stabilized. Don't give it an ounce more refrigerant than it needs to do its job. And with CO2, I'm going to say 99% of the stores I've done, it's all been temperature control with superheat limit. And I mean, these are beautiful graphs. That's exactly what you want to see. This is getting your money's worth out of electronic controls. If you pull up a graph and it's haywire and it looks like a mountain chain with a bunch of ridiculous spikes all over the place, you got to go in and you just like Kevin said, there's off the shelf. We make our best scientific estimate of where it should run, but you should come back and tune things up so that it runs like a top. And then once it's run like a top, it's up to you. We do have customers that once they've done a run of about 6 months, they really are strict and they lock the system down. And instead of giving configuration, they may only give maintenance permission. And that will limit a lot. You see how this pallet went away? That'll limit a lot of what you can do at the store. Again, it's the end user store, but what they want to do is they want to lock down that performance envelope so that it doesn't drift away over time, and then the store becomes an energy hog.
Yeah, plain and simple. That 700 series case controller is probably one of the best case controllers out there, if not the best. Like that controls cases so much tighter than anything I've seen in all the abilities you have to tune everything.
Yeah, and Kevin, and the reason for that is, when you open it up, oh, see what I did? You always have to remember, it looks like it's going to, I always try to be in configuration if it allows me, but your system information has to be set up correct. Your configuration has to be set up correct. You got to double check your inputs and outputs. But the reason it gets to be so smart is there's a valve setting. Let me put my Okay, there's a valve setting. Okay, so again, here's the base value for this case. It's 20, 2.5 times 20. So the maximum under refrigeration, not after defrost, under normal refrigeration, this valve will never go over 50%. Then there's a superheat algorithm. There's a pull down algorithm. There's a temperature control algorithm. There's an environmental correction. Now, they're not using that because I think this could be a POS. There's defrost algorithm. So you have all of these algorithms set up. And again, that's how we get those case controllers to be so tight, because there's so many correction factors running concurrently in the control. That's why we're able to get graphs. Let's just take a look at another one. This is looks like frozen food, and we'll take a look at that. Oh, jeez. I got to tell you, man, that's a thing of beauty right there. I mean, I'll zoom it in. When I first got into this business 40 years ago, I thought you could only do laboratory control that tight, but you can't even see the difference between the blue and the green line because they're right on top of each other. That's how tight it is. So here's another cool thing you can do: trend graphs. So somebody's already set this up. So here's your control temperature, and here's your circuit control temperature. Calls for it, and you can build a total of 7 graphs within any of our nodes, and then you can save it in history. And then if you've got a bad actor and you need to come back to the store in another week or another month, you don't have to recreate all of these graphs again. You've just got to say you've got it saved in history, and you pull it up when you have to come back to the store and troubleshoot. It's already there for you. Well, guys, thanks a lot for spending the time with me. I really appreciate it.
No, I appreciate you coming on, man. I love when we do podcasts like these because I learned so much. You know, I like you said before. I would love to have you on again. Talking about different aspects of some of the different controllers, some of the other
Sure.
troubleshooting with that.
hmm
Kevin, did you have anything else?
I think that's it for tonight. I mean, this was a good one. This is going to end up being 2 episodes. I mean, we got a lot
Yeah,
of
for
time
sure.
down to this. So I would love to have you on again, Charlie, and
Sure.
maybe we could set up something with Michael and do the MPC stuff. And
Yep.
I mean, I think that'd be great. And I mean, you guys are going to get a lot of experience out of this. So I really appreciate you taking the time and talking with us.
My
Um,
pleasure. Thanks for the invite. I appreciate it.
Before I forget, guys, there is a document out there, best wiring practices for Microthermal. It shows you how things should be wired, the rules of thumb, a lot of the stuff that Charlie went over. But just be mindful that that document does exist. And if I can, I'll try to put it on the Advanced Refrigeration podcast Facebook group. I'll put a link to that file on there so you guys can read through that if you like.
Awesome. That's a great point. We do have one on wiring, and we do have a bulletin on network architecture. So that's available. I could get you the bulletin number on that too.
Yeah, absolutely.
Cool.
Beautiful. All right,
Well,
guys. Thanks for listening, and thanks for coming on, Charlie. I appreciate it.
my pleasure, guys. Thanks for inviting me.
All right. Have a good night, guys.
All right. Take good care.
All right. Bye.